Assalamualaikum and good day to everyone. So I made this video to replace our class for week 2, whereby we had a holiday for Deepavali. So I will continue on our topics that we have learned last week. So last week we have stopped at attributes and methods. So now we continue on abstraction. And again, please don't worry, because we will have a dedicated chapter just to discuss on every terminologies. Okay, so there are many terminologies in Java, so we will have chapters that will cover on those. Okay, so don't worry. So at this time, you just only need to understand the concept only. Okay, later on we will learn thoroughly about each of the terminologies. So we continue on abstraction. So what is abstraction? Okay, abstraction aims to hide complexity from the user and show them only the relevant information. For example, if you want to drive a car, you don't need to know about its internal working. So same goes with Java. Okay, for example, last time I have shown you this code. Okay, if you notice here, we call a predefined function, okay, or a predefined class, name scanner. Okay, the name of the class is scanner, and then we use this scanner class, okay, over here. Scanner, we create an instance of scanner, we name it as input. Don't worry, we will learn this later on. Okay, as of now I just show you the example, what is abstraction. So we are using scanner class on this main.java. Okay, so scanner class is actually a code, okay, a code that has been programmed by the Java developers. So what I mean here is we only use it. Okay, we don't need to know how it operates. Okay, the operation behind the scanner class, how it works. Okay, it just we call it and we use it. We don't need to know the operation or what is inside the scanner class. Okay, that's what it means by abstraction, whereby we only use it and we don't care about how it works. Okay, so you can hide internet information details by using abstract class or interface. Okay, this one we will cover later on. Yeah, on the abstract level, you only need to define the method signature or name and the parameter list, and let each class implement them in their own way. Okay, there will dedicated chapter for abstract class later on, so don't worry. Okay, right, next is on encapsulation. So encapsulation is a key concept in working with objects. Whereby it combines the attributes and also functions or methods in one package, and it hides the implementation of data from the user of the object. If you notice before this, when you learn C programming, right, so the variables here are the variables, and the functions or method are separate entity. Okay, but this time when we learn OOP or Java, variables and functions resided in one entity, okay, in one place, meaning that it is kept into a single class. Okay, so it can interact each other. As compared to this, whenever we want to interact, we need to pass through parameters over here, num1 and num2. Okay, the key to making encapsulation work is to have methods that can never directly access attribute in a class other than their own. Okay, if we look closely over here, these are the methods of function whereby it can access number1 and number2. Okay, take a look over here, number1, okay, whereby it can access number1 directly. So in this line, it assign number1 equal to n1, and 1 is over here. Okay, so we set n1. Okay, firstly we set n1, and then number 1, this one, number 1 will equal to n1, the one that we just set. Okay, so that is the concept of encapsulation, whereby we need to have a method, okay, that can directly access the variables. Okay, and then the program should interact with object attributes only through the object methods or the objects function. So this class or this variable, okay, only can be accessed with its own function. Okay, it cannot be accessed by functions outside. Okay, look closely in this class. Okay, all the variables and functions are kept, okay, are kept inside these brackets. So these variables, number 1 and number 2, only can be accessed by their own functions. Okay, so there are 3 functions over here: set number 1, set number 2, and lastly get addition. Only these 3 functions can access number 1 and number 2. Other functions outside cannot access number 1 and number 2. Okay, that's the thing. Okay, by encapsulating objects attribute, you maximize reusability, reduce data dependency, and minimize debugging time. Okay, next is data hiding. Okay, data hiding makes your class attribute inaccessible from the outside by providing the getter and setter method for attributes that shall be readable or updatable by other classes. Okay, this one also will be covered later on. Okay, so if we notice over here, okay, there's a prefix before the variable declaration. Okay, if you look closely, we have private prefix over here. Okay, what does it mean? Okay, as the name suggests, okay, private meaning that this number 1 and number 2 are being hide, okay, is hidden. Okay, and these 2 variables are hidden, whereby it only can be accessed or visible only by their own functions. Okay, whereby the function will be set number 1, set number 2, and get addition. Okay, what if I put this as a public? Okay, if I put this as a public, then it can be accessed from other functions too, from other classes. Okay, but the normal way of implementing encapsulation is to declare all the variables as private. Okay, so normally what we do in OOP, we will implement encapsulation whereby all the variables will be kept hidden. Okay, it will be kept hidden, and the only way to access the variable is through the methods, its own methods. Okay, so in this case, those methods are set number 1, set number 2, and get addition. So we call this method as setters and also getters. So how do we differentiate them? Okay, if it is a setters, okay, it will start with the set keyword, okay, before the function name. Sorry, the function name we put set. Okay, set what? We want to set number 1. So we name the function set number 1. And then this one set number 2. As the name suggests, we want to set the value of number 2. Okay, so these 2 are setters. We call them as setters. And then the last one, we have getters. Okay, normally it will start with the keyword get. So as the name suggests, what we want to get is the value of addition of number 1 and number 2. So this is getter. These 2 are setters. Okay, so that is the way of accessing the private variables. Okay, don't worry, again I repeat, we will have chapters that cover on this. as of now, it's just sufficient that you know the concept first. Okay, this one, I think all of you have learned about software engineering, right? So in software engineering class, you have learned on how to draw a UML diagram. So this is a UML diagram. Okay, let's say the object is car. Okay, and then we list out all the variables. Normally the first row will be variables, and then the second row we list all the functions or method. Okay, normally the variables will be private. We set them as private, and all the methods or function we set them as public, just like this example. Okay, if we notice, all the variables are private, however the functions, okay, including the setters, these are setters, and this is getter, all of them are public. Okay, so this is how we translate our object or our class into UML. Okay, and then don't forget to include the data type. So normally data type we put after the name of the variable. The name of the variable is name in this case, and then the data type is string. Okay, and then the second one, the name of the variable is top speed, and the data type is double, right? So same goes with the functions. We have getters over here, get name, and then it returns string. Okay, this one, set name, it doesn't return anything, so we put it as void, right? Okay, next is inheritance. So inheritance is the ability of one class to extend the capabilities of another, whereby it allows code to be defined in one class and be reused in other classes. Okay, consider a class named car. A car is a specialized form of the vehicle class. Okay, let's take a look of this example. Okay, so normally inheritance, we have what we call as parent class. Okay, this is parent class. Okay, this is parent class, and these two are child class. Okay, car and pickup are child of vehicle. Okay, so parent class will be on top and child classes will be at the bottom. Okay, here's the thing, inheritance means that these child classes will inherit all the public members over here. Okay, all the public members. Okay, let's say that all these attributes are public. These are public, and then the functions also are public. So what does it mean? That inside car over here, it can access make variable. It also can access model. It also can access color. Okay, it doesn't restricted only to access. It also can define, okay, the value of make, the value of model, the value of color, and so on. Okay, if we notice over here, okay, car only has two variables. Okay, so when we implement inheritance, okay, what it means that we allow our code, okay, to be reused. Okay, to be reused from other class. Okay, we have written this class, right, vehicle, and then later on we write another class, and then we want to reuse whatever that we have written over here. Okay, so that is the concept of inheritance. okay, we derive some of the attributes and functions from the parent class. Same goes with pickup. Okay, pickup will also inherit all the public attributes or the public methods from its parent, which is vehicle. Okay, so it allow us to save our time lah whenever we want to code our object or our class. Okay, because we can inherit from another code or another object that we have written before, so we don't need to rewrite again. Okay, next is polymorphism. It means many forms. Okay, a reference variable is always of a single unchangeable type, but it can refer to subtype object. A single object can be referred to by reference variable of many different types as long as they are the same type or a supertype of the object. The reference variable type, not the object's type, determines which method can be called. Okay, it's easier if I show you example. So let's say, okay, in order to first thing, in order to apply polymorphism, we need to apply inheritance first. Okay, meaning that we are working with a class or with our code, and our code is inheriting others code. Okay, some other code. Let's say car inherits vehicle. Okay, so in order to apply polymorphism, first thing is we need to apply inheritance first. We need to have inheritance. So whenever it comes to inheritance, we have parent class. Okay, parent class, the class on top, and we also have child classes at the bottom. Okay, take a closer look at this parent class shape. Okay, so normally parent class is a generalized class. Okay, and the child class is the specialized class. Okay, so for shape, we have a method name area. Okay, however, in its child class, which is circle, triangle, and rectangle, they also have the same function. Okay, however, okay, the definition or the operation is different. The only thing is the name of the function is the same. This one area, this one also area, this one also area, this one also area. However, the calculation or the operation is not the same. I think all of you know, right, how to calculate area of circle. It is not same with the calculation of to calculate the area of the triangle. Same goes with rectangle. The calculation will be different. Okay, so the thing here is polymorphism allows us as a programmer to override. Okay, the keyword is override. Polymorphism is equal to overwriting an existing function. Okay, we have area of the parent, and then inside the child we call it we inherit this area function. However, we override it. Okay, what do we override is actually the calculation. Okay, the calculation of area. Okay, so polymorphism is overwriting an existing member variables of the parent class. Okay, last is advantages of OP, whereby we can reuse our code. Okay, just now I mentioned about inheritance, whereby we can reuse the variables and the methods that we have written before. Okay, and then extensibility, a way of moving traditional software towards object-oriented software. Instead of adding application, OOP allows adding of small modules that work together to replace the notion of isolated application, which means we can put together whatever additional function that later on we work on later on. Okay, so it allows extensibility. And then lastly, maintainability. Maintaining the software or system will become easier and cheaper, and software or system is built with smaller and many applications. Because in first class, right, I mentioned about whatever code that we write in OOP, we must think of the object first. Okay, so every object should have its own code. Okay, we do not combine every object into a single code. Okay, that is a traditional way of procedural. If you write in C, yes, and you can apply those methods. But if you write in OOP, you need to separate the code of every object. Okay, so it allows better maintainability. Okay, so I think that's all for this session. Inshallah, I will see you later on week 3. Okay, until then, Assalamualaikum and have a nice day.